The illegal wildlife trade has been going on for decades, but it is quite organized, makes a lot of money, and is very bad for biodiversity. The trade in elephants for their ivory, pangolins for their scales, tigers for their bones, and many more animals for exotic pets, trophies, or therapeutic products is destroying the globe. This is a global industry worth billions of dollars. Traditional conservation methods are really important, but they often take too long. By the time rangers get to a poaching site, the damage has already been done. The problem that environmentalists are facing right now is not whether or not they should do something, but how they can keep one step ahead of criminals. More and more people agree that artificial intelligence has the key to the problem. Artificial intelligence systems can sort through gigabytes of data in seconds, find patterns that humans can't see, and work around the clock, unlike human patrols or manual monitoring. Machine learning algorithms learn from data that has already been collected and get better at spotting small signs of illegal conduct. But instead of just responding, they plan forward. This change in capabilities means that the front lines of animal protection are moving from reactive policing to smart prevention. One of the biggest problems that has come up recently on the internet is traffickers have relocated their businesses online, where they may hide among the millions of real e-commerce listings and social media posts. This is because people are paying more attention to traditional wildlife markets. It's like finding a snow leopard in a snowstorm when trying to find illegal wildlife trading in a huge amount of content. In China, Baidu and the International Fund for Animal Welfare, IFAW, are working together to fight the digital jungle that is hurting the country. With an accuracy rate of 86%, its AI Guardian of Endangered Species 2.0 solution can find 34 species that are often sold online. These animals and plants range from tiger skins to ivory sculptures. The old version of the software looked at 360,000 pictures, found more than 21,000 suspicious posts, and got rid of thousands of them in less than a year. Researchers at the University of Helsinki in Finland are using natural language processing and machine vision together to sort through the noise on social media. The AI's capacity to automatically filter out superfluous messages cuts the evaluation pool for human analysts by more than 90%. Think about how much easier this makes things. Instead of going through a million random tweets, an investigator gets a list of possible wildlife crimes. The WWF's Seashell program also makes this power available to anyone with a smartphone. If you take a picture of a guitar pick or comb that you think might be made of tortoiseshell, the AI will tell you if it was manufactured from a hawksbill turtle, which is in a situation of critical endangerment. Is it possible that soon, every traveler, tourist, and customs officer will be able to find wildlife crimes? Detection is really important, but prevention is much better. It comes into play when predictive analytics are used. The University of Southern California built the PAWS, Protection Assistant for Wildlife Security system, which uses game theory and machine learning to predict where poachers will strike next. It does this by looking at past data on poaching, patrol patterns, and environmental factors to build patrol plans that cover the areas with the highest risk. This plan led to a 30% rise in the number of snares found at test sites in Uganda and Cambodia. This not only makes things work better in places where resources are limited, but it also gives a vital lifeline to animals that are about to go extinct. Also, field operations are going through a digital transformation right now. Trail guard cameras, which use AI to work, can spot people doing things they shouldn't be doing in the Dudhwa Tiger Reserve in India and sound warnings in as little as 30 seconds. In the old system, you had to wait several weeks to get memory cards back from camera traps, just to find out that poachers had already come and gone. In the Similipal Tiger Reserve in Odisha, 140 of these cameras were employed. They helped catch poachers in 80% of the cases that happened in the last 2 years. Archival material was a big part of putting together legal cases. If these systems were used on a big scale, how many more reserves could be changed in the same way? One of the most inventive ways to solve problems is to make nature an active participant. Researchers have given vultures in Uganda's Murchison Falls National Park GPS devices that use artificial intelligence. The birds, who are inherently scavengers, turn into living drones that watch over things. If their flight patterns show that they have found a dead animal, the system tells rangers so they can act before the evidence is lost. In one case, This gave the police a crime scene and clues that led to the discovery of a recently poached buffalo and disguised snares. Footprints can also exist in a digital world. The footprint identification technique established by WildTrack used to be done only by hand, but now it has been improved with the use of drones and AI that can discern species and even individual animals apart based on their prints. This is more than just keeping an eye on the population. It's a secret way to find out if people are poaching without having to talk to the people who are doing it. Artificial intelligence platforms like Conservation AI are combining transformer models with convolutional neural networks on a global scale to analyze visual and thermal images taken by camera traps and drones. The device can tell the difference between animals, people, and even weapons that are in the frame. It has been used in Africa, Southeast Asia, Europe, and North America. The Wildlife Enforcement Monitoring System, WEMS, serves as a central intelligence hub in the meanwhile. It collects and analyzes data on wildlife crime from several nations to find trafficking routes, seasonal patterns, and policy gaps. But technology alone can't fix everything. Models of artificial intelligence need to be able to change all the time to keep up with the traffickers' changing tactics. If thieves change how they image or talk about their goods, the algorithm we use today might not work tomorrow. Rural areas often don't have the internet access they need to send out messages in real time. Also, using surveillance methods raises a lot of tough ethical questions. Aren't utilized for anything other than monitoring who owns the data, and how can we find a middle ground between the necessity to protect species right now and the worries about privacy? Even with these problems, it's hard to ignore the results that have been achieved thus far. Artificial intelligence is helping rangers get to places before the killing happens, customs officials stop shipments before they get to the black market, and rangers get help. This is giving conservationists the early warning they have always needed. The main goal here is not just to conserve animals, but also to break up the networks that profit from the loss of species. The stakes are way too high. The most amazing beings in the world may or may not still be around tomorrow, depending on how well human willpower and machine intelligence work together. In this fight against extinction, artificial intelligence is becoming more than just a tool. Thanks for watching. Don't forget to like and subscribe to our YouTube channel.